We are on page 33, and we're gonna look at this Explore. We're gonna kind of make a conjecture about zero exponents here. So we are still in module 1, but we're already to lesson 4. So these 4 lessons are what is going to be on your quiz. No, do you need me to turn it off? Yep, okay. Big deal. So let's explore exponents of 0 first. So what does it mean when a number has an exponent of 0? So if we have the expression 2 to the third divided by 2 to the third, our quotient rule says we do what with our exponents? Quotient means to divide, but we're going to do what with our exponents of the same bases? Do we remember? Maybe we have to, we're going to subtract. There we go. So we have 2 to the 3 minus 3. Well, what's 3 minus 3? 0. So we have 2 to the 0. What if I just had 2 divided by 2? What would you tell me that was? 1. So 2 to the third divided by 2 to the third is 2 to the 0 or 1. Look at you guys. You don't even need me. You've taught yourself. So here they're showing you with the quotient of powers property that this is 5 minus 5, which is really what? 0. 3 to the 5th power. Well, I would have to look it up. Remember, you can use your calculator. You can put in 3 caret 5. Good practice, right? 3 to the 5th power is 243. 243 divided by 243 is equal to what? Anything divided by itself is 1, right? 4 minus 4 is 0. 4 to the 4th, we should know this one maybe. No, we shouldn't. 4 to the 4th is 256. 256 divided by 256 is what? 1. Very good. And then this is the 5 to the 2 minus 2, which is 5 to the 0 power. So 5 squared we know is 25. 25 divided by 25 is 1. So anything to the power of 0 equals what? 1. All right, can I clear that? No? Okay. So here's what we know. And so without calculating, to what do you think 7 to the power of 0 simplifies to? Zach? 0. No, not 0. Lord have mercy. What did we just find them all? 1. Oh. 1. So 9 to the power of 0 means that is 1. And 15 to the power of 0 also means it is 1. All right, we'll get there. So what does it mean when a number has an exponent of 0? It means that that simplifies to 1. All right, so let's look at our learn here. It says use the 0 exponent rule to simplify expressions containing exponents of 0. Any non-zero number to the 0 power is equivalent to 1. So 5 to the power of 0 equals 1. Okay? Any questions on page 33? That was pretty easy peasy, right? Now that we know. So we're going to turn to page 34. All of these powers are going down 1. So this becomes n times n times n times n. Four factors of n, right? N to the third is how many factors of n? 3 factors of n. This is 34. N squared means we have 2 factors of n. N to the first means we have 1 factor of n. What if we divide n by n? We have what? N divided by n equals 1. Every time we're dividing by n, we're canceling one n out, or we're subtracting one exponent here. So the pattern in the table shows that as you decrease the exponent by 1, the value of the power is divided by n each time. By extending the pattern, n divided by n equals 1. So n to the 0 power equals 1. Write the expressions that are equivalent to 1 in the bin. Is 2 to the first power equivalent to 1? No, that's just 2, right? How about 1 to the second power? 1 times 1 is actually 1, right? So 1 squared we can put in the bin. How about 2 to the power of 0? Yes. So 2 to the power of 0 equals 1. How about 1 to the power of 0? Yes. How about 0 to the power of 1? No, that would just be 0, right? A factor of 0. 1 factor of 0. How about 1/2 raised to 0? Yes, still 1. What is an equal sign with a dash? An equal sign with a dash through it means does not equal. So you are looking at, right? Oh, the check problem. Okay, we'll get there. As long as m does not equal 0, right? Because here, if we had 0 to the 0, it wouldn't be. We'd have 0 divided by 0, which would be 0, or actually undefined. Oh my gosh. Apparently I did. All right. Simplify 12 to the 0. Any non-zero number to the 0 power is 1. So as long as m does not equal 0, m to the 0 power also equals 1. Oh my God, that was so hard. All right, so hopefully this isn't too tricky. Let's look at the exploring negative exponents, which we've looked at a little bit with our boom decks, right? So if you didn't understand the boom decks the first time around, I think the second time around will be helpful to you. I got it. We're not going to boom decks right now, nope. But we have looked at negative exponents in our boom decks. We are probably going to do boom decks on Monday unless we go really fast today. I kind of have them there just in case. We'll see. Negative exponents. So how can you simplify an exponent with a negative base? A base with a negative exponent. All right. A cake is cut into 16 pieces. You serve half of the pieces to your friends. Each day you continue to serve half of the remaining pieces until one piece of cake is left. So complete the table to show how many pieces of cake are remaining each day, both in exponential form and in standard form. All right, standard form just means it's the number. What's 2 to the second power? 4. 4, right? So 4 divided by 2 is 2. See, each time we're dividing by 2, 2 divided by 2 is 1 until we have one piece of cake left. That's what it told us to do. So what do you notice about the exponents each time the power of 2 is divided by 2? Each time it's divided by 2, it's half of that, right? So what do you think is going to happen when we divide 1 by 2? We're going to have a half, right? So let's look. Yay, correct. We did it. 3 of 7. So Notice that 2 to the 0 is the last expression, which represents the one piece of cake left. Predict what the simplified form of 2, which is 1 divided by 2, is written in exponential form. So if we have if we have 1 over 2, remember how we had to put that? We had to put the negative stuff into the bottom. So if we divide by 2, we're going to end up with 2 to the negative 1, which is 1/2. So it's going to keep subtracting an exponent. If we divide by half again, we have 2 to the negative 2, which would be 1/4. So we're going to look at this some more. Divide by 2 again. So every time we divide by 2, we're subtracting an exponent of that same base, right? So it's going down, down, down. Will it ever get to 0? You'll just have smaller and smaller pieces of the cake, right? All right, let's look at our notes. So that was our online activity at the bottom of page 35. Page 36 starts our learn here. We're going to do the same thing again, but we're going to divide by 10. So 3 zeros is 1, 2, 3, 1,000. 1,000 divided by 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1. 1 divided by 10 is, no, 1/10. 1 divided by 10 is literally 1 divided by 10, right? 1 fraction bar 10, or 1/10. So if I divide by 10 again, nope, I still have 1 on the top. What's 10 times 10 on the bottom? 100. 1/100. And then good, 1/1000. So you see the pattern, right? Your denominator is getting bigger. Once we are in this negative exponent, our denominator is getting bigger. Remember, on our quotient rule boom deck, we would have written this as 1 over 10 to the first, or 1 over 10 to the second, or 1 over 10 to the third, because it wouldn't allow us to write them. That looks like 103. I'm sorry. I can't write my 3 that small, apparently. It's hard to see. Because we can't use a negative exponent, so it gets a little tricky there. So any non-zero number to the negative n power is the multiplicative inverse of its nth power. Do you see how this is 10 to the third down here? This is 10 to the second on the bottom here. This is just 10 to the first on the bottom here. Absolutely. So if I have 7 to the negative 3, I really have 1/7 times 1/7 times 1/7, or 1 over 7 to the third power. Remember, I told you to put the negative exponents in the basement so they could stay positive down there? Hopefully. No. All right, so let's look at an example on page 37. Instead of writing 6 to the negative third, we put 6 to the third in the basement. It goes into our denominator. I call our denominator the basement. We don't want any negativity on the first floor, right? So 6 to the negative third is expressed using a positive exponent is 1 over 6 to the third. So how would you express a to the negative fifth using a positive exponent? So using what you know here, how would you express a to the negative fifth? 1 over a to the 5th. 1 over, good. So our numerator is 1, and then we put a to the 5th below it. So we need to understand how to go from negative exponent to positive exponent. And we also need to understand how to go from expressing a fraction using a negative exponent. So 1 over c to the 5th is really c to the negative 5th. So 1 over c to the 5th expressed as a negative exponent is c to the negative 5th. How would I express 1 over 9 to the 7th using a negative exponent? What would I do? Try that test. All right. So this would be 9 to what power? Negative 7. Good. So do you see how we can go back and forth from these two examples, 2 and 3? Yes. All right, let's look at example 4. So we have to remember our product of powers property. When we have the same base and we're multiplying them, what do we do with our exponents? We add. We're going to add our exponents that have like bases. So 3 plus negative 5 is really, what's 3 minus 5? Negative 2. So we have 5 to the negative 2. And then we have to write that using a positive exponent. So we put it in the basement. 1 over 5 to the positive second. Simplified, what is 5 squared? 25. 25. 5 times 5 is 25. So 1/25. All right, try the check. Remember what they did here. They added the exponents. So what are you going to do here? Same thing. Add the exponents. Try that check. All right, so our base is 3. We're multiplying common bases, so we're going to add the exponents. 9 plus a negative 4 is what? Careful. Positive 5. 9 minus 4 is 5. So if you wanted to figure out what 3 to the 5th power is, you can put it in your calculator. And that is 243. Mm-hmm. No, I did not. Yes, all right, here's another example, but this time we're using the quotient of powers property. Remember, our quotient of powers property means we subtract exponents of like bases. So what is negative 1 minus a negative 4? No, it's not. We have to switch. So 4 minus 1 gives us W to the 3rd power. So try that check on the bottom of page 38. Remember, with our quotient property, we take the top minus the bottom. Be sure you keep change. No. So if we're using our quotient of powers property, our base is B. We're taking the top, which was the top exponent, that is, which was -7, minus the bottom, which was -4. So if we keep change, we have -7 plus 4, which is what? B to the -3, because we have more negatives. You can draw them out. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. You're left with these 3 negatives. So b to the -3, how would I write that using a positive exponent? 1 over b to the 3rd. Oh, sorry. Yep, you're fine. You knew what you were doing. So that's as simplified as that gets. So now we're going to turn to page 41, and we have some practice, and it looks like that's what we'll get through today, is this practice. 1 through 12 on page 41. Page 41. Hopefully these two are very simple, right? Express these using positive exponents. Express these using negative exponents. Positive exponents are you write it in the base next, like yep. And then remember our product rule. We add our exponents. And our quotient rule, we subtract exponents. So hopefully that helps you. All right, my dears, let's look. Anything raised to the power of 0 equals what? 1. So number 1 was 1 and number 2 was 1. How do I express this as a positive exponent? Sure, you can help me. 1 over 8 to the power of 4, or 8 to the 4th. 1 over y to the 9th power. 9 to the power of -6. Careful, I think that's a D. Oh. So this is D to the power of -6. It looks like a 9. I mean an A. An A. It does kind of look like an A. And this is 10 to the power of what? -5. Now here, this gets a little tricky. Our product rule says we have to add the exponent. So I'm saying 4 plus a -6. If you're still struggling with your integer rules, use a calculator. What's 4 plus -6? Careful. 9 to the -2. So how do I have to simplify it? 1 over 9 squared. Yep. 9 to the power of 2. So be sure you simplified it so that you have positive exponents. That's fully simplified. And then we're going to do the same thing with this one. We have y to the -9 plus 3. What's -9 plus 3? So y to the negative 6 is equal to 1 over y to the 6. So be sure it's fully simplified. In order for it to be fully simplified, we need positive exponents, unless it's asking us to write them as negative exponents. All right, quotient rule. Remember, we're going to subtract our exponents with like bases. So we have x to the negative 8 minus a negative 12. When we subtract an negative, we're really adding it, right? So we really have more positive than negative here. It is.
Do you have to simplify it?
That's as simplified as it gets. If we have a positive exponent, we can stop, right? So D, we have negative 13 minus a negative 2. So it's getting a little less negative. So D to the negative 11. Are we done yet? We have to simplify because we need a positive. So we need to write it as 1 over D to the 11th. We have two different bases, right? So we can look at our 8s first. What's negative 7 plus 7? 8 to the 0. We can look at our 10s. What's 4? Yes. What's 4 plus negative 4?
0.
Also 0. So 8 to the 0 is 1 times 10 to the 0, which is also 1. 1 times 1 is 1. All right, so select all of the expressions that are simplified. N to the 4th. It's positive and it's in its simplest form. 1 over n to the negative 5th. How would we simplify this? We need a positive fraction, so we would put it from the bottom to the top to make it positive. So that one's not simplified. This one, we would have to add our exponents to simplify it. What's 6 plus negative 8? N to the power of 2, negative 2, which is then simplified to 1 over n to the 2nd power. This one's not simplified either, right? We would have to add our exponents because we have the same base. So this would be n to the 15. And 1 over n to the 3. That's as simplified as it gets, right?
Yep.
So just the first one and the last one there. All right. So far, so good. So next week, we're going to be practicing all of these. I'm going to give you a cheat sheet for more notes on the rules. We'll have some more boom decks. We'll have a review. Okay.